All right, so hello everyone. My name is Thomas Yu from KNN3 Network. I'm the co-founder. And today I'm going to introduce about how to create a Web3 data economy with blockchain user behavioral data with HTAP technology. All right, so first of all, thanks for the invites from the PingCAP. It's a great honor to share with those industrial leaders about what we are, so what's the user experience we're building in the Web3. So a little bit about myself and my team. So I'm the co-founder, and I was previously worked for BC China and the AB InBev China innovation team, and also investment analyst of Fundamental Lab. And I also worked for Chainlink as DevRel and a solution architect. All right, so KNN3 Network is a multi-chain data app engine to empower DApps and smart contractors to build a more, let's say, smarter and more fun, more excited application on social discovery and on-chain reputation and all those intelligence stuff. All right. So today in my presentation, I have 3 goals. First goal is to discuss a little bit about the Web3 data challenges that we're facing today. And secondly, I'd like to share a little bit for our partner, PingCAP, and its technology behind the HTAP, and what's the user building experience we had. And also, I want to call to action for those industrial leaders from Web2 or on data or on cloud or on AI infrastructures. If you are following in any of these industries, it's a great time to look into what's happening in Web3 right now, because industry is booming. All right. The first thing we're talking about, the booming, is the application is booming, and the underneath data, right? So I think you guys are familiar with this graph, right? So Web 1 is like the single direction interaction, the creator generating contents and send to users. Web 2 is more like interactive information sharing. So user can be the generator and also can be the content consumer. But in Web3, what's changed, right? What changed is the data itself. How do we see the change of data itself? So in Web2, it could be a data is just a piece of information. The information could be true, could be false. But in Web3, those data are verifiable. So that means it can be a piece of assets, or it's a proof of action, or it's a proof of privilege. So underneath of that, we have a series of DApp applications, blockchain applications, hacking on the storage and privacy, browsers, and all other applications coming out. As the application boomings, and we can see the Web3 data is fast growing. Right now, so we are almost in the time that the Ethereum's full sync data size is going to hit 1 TB. This is a very large size, given those data are all verifiable, and not regardless to say we have Polygon, BNB chain, and Solana, and all other compatible chains. But underneath of that is not only the size of data, it's also the value of data. Right now, we have 5.1 billion data backed by those define or stored in those defines. So we call that total value locked, or TVL. And those value is increasing fastly. As you can see, from 4.7 to 5.1 billion, it's only take 2 days, less than 2 days happening. So, but also the volatility is high. All right, so what's the difference from Web 2 data and Web 3? I give 2. So the list could be going very long, but this primary key takeaways I want to share with you guys. First is the verifiability. So in Web 2, the data is the vehicle of information. But in the Web 3, the data could be a notation of assets. Also could be a proof of privilege, could be a proof of ownership, proof of social stats, backed by a series of the social or verifiable social behavioral data. And another is interoperability. This is also something we're not seeing in the Web 2 a lot. Think about that. If you build a new startup in Web 2, and you want to use Facebook's data or Google's data to bootstrapping your application, the only way you can do is buying media advertising from Facebook or Google, right? But why you have to do that? Because all those user behavioral data are the private assets owned by those corporations. But in Web3, the control and the sovereignty of those data are owned by user itself. And also, those data as information is collectively owned by public, so we can regard it as a public facility. But we also facing some challenges right now in the Web3. As a Web3 developer, the first challenge we are facing today is if I'm building an application on Polygon, it's very hard to interact or access the data on Ethereum, not even to mention Solana. It's totally different virtual machine schema. Right, so those data are segmented, even though those data are valuable, but they are segmented in different places. How do we just mining it, right? So it's time for thinking about mining it. And another common issue we call the state explosion. Those terminologies are originally came for the issue that we're facing on the Ethereum scalability. But today, we have a lot of scalability solution. We have layer 2s, we have POW to POS, and we have high-performance blockchains. And the data is fast growth. And every second, or let's say every block, accurately, every block, the data is generating. So how do we consume it real-timely so that we can empower those applications building more interactive? So just to give a summary. Again, the list is going on and on. But data availability means those data are poorly structured and indexed and segmented on the different blockchains, different platforms with different data schemas. And secondly is the data usability. Today, if you want to run a GNN on top of a graph knowledge database, it's merely impossible. Otherwise, you have to build it by your own. And also, we have a very long latency on timely feeding. All right, so back to how can we build a multi-chain data to empower Web3 social apps? So first thing that KNN3 is doing, so we built a product called GraphX. It's a cross-chain user behavioral data and identity and social data aggregator. That we put identity, user's identity or account together. And also we collect those user behavioral data from the multi-blockchains together. And also we collect those social status of those user or those accounts from the different protocols together. So we put everything together. It's something like this. Right? You might be familiar with this, so this is just another graph, right? But the difference is we don't build any new things, or we don't create any new data. All those data are collecting from some part of the blockchain and from certain people on the blockchain. And this graph is real-timely synced from, subscribed from the different blockchains. What we can build. So this is the product that we built in the ETH Global Hackathon. Actually, I can show you guys how it looks like. Right. I'm just opening. All right, so it looks like a bean, right? So it's a searching tool that you can put anyone. So I just put Stanley, one of the RV's founder, because he got a lot of the actions. So you can see Stanley has a lot of the NFT assets, which we call the collections. And Stanley has multiple ENS. And Stanley, or related to Stanley, there's a domain and also lens. And as you can see, here we have a page rank. We literally put the score on the side of it so people can see it. All right. So the page rank is running periodically on top of the graph database. And this I will explain later why we use the HTAP too. All right, so we go into it. You can see this is Stanley's social profile. And in the list of it, so you can drag any of this. So those are the Ethereum address. So in any of those Ethereum address, you can expand implicit or explicit relations from follower or social stats NFT or lens protocols and other events like recorded by POAPs and also avatars aggregated by DIDs and also governance if you vote on the snapshot. And also if you own a domain like .bit, then you can explore as the clue, right? So I just back to the presentation. All right, so today, since we're in the HTAP summit, so we're gonna show some technical challenges that we're facing. So first, as I mentioned, data size and future scalability are something we're considering. And then secondly, hybrid demand on CP and AP. Some data are too large to be consumed transactionally. And also, we have to handle huge throughputs of streaming data in real time. And in the business level, we have to balance among cost, performance, and the future extending flexibility. Right. So this is one of another product or another data product is a tagging database, helping those on-chain reputation program to tagging users' actions on any blockchains that we can access to and convert them into either the threshold of credits or true false or Boolean tag to additionally allow them to decide whether a user is eligible to get some rewards or get some future privilege. So it has been applied by Quest 3. It's a campaign tool to helping them recognize who is the eligible user to get the privilege in a marketing promotion. All right, so this is our system architecture before we use HTAP. So we got the real-time data from multi-blockchains. It's large, and because if you came here earlier, Coinbase already shared the headache of that. So, but we use ClickHouse. We use the ClickHouse cluster as a primary data. So we dump everything together after ETL service. And then we put it into the stream data process. And after some streaming data service, the data we're dumping into the PGSQL. But another challenge is, so one way we have to convert those data into the graph. So PGSQL, we're eventually using Neo4j, and also right now we have the TiDB, TiDB helping with that. But also, some other use case requires the AP. AP means like you have to periodically do the settlement to make the calculation ready. So those post-processing will go through a KVDB. It could be S3 or MongoDB, and then you deliver the data. So this part spent us like half a year, almost a half year for the backend team or data team to dodging on those solutions back and forth. But eventually, we decided to replacing them with the TiDB. Because as you can see, we have two purposes here. One is real-time or transactional subscription data that we needed to digest. And secondly, we have periodical post-processing data we needed to consume or we needed to deal with. And with the HTAP's architecture, it solved it well. At least, well, regardless of the cost, it helps us a lot because we only have like 8 people in the tech team and only like 4 people in the data team, and we are not specialized on that, and we don't want to specialize on that. So the better way is like we can delegate those issues to who is a professional on it. All right, so today this is the core part, right? So how like HTAP bring 2-in-1 convenience. So you might say, okay, so here what I want to talk about is the cost. If you're running a business, you always care about the cost, right? So if you only use the TiDB cost is definitely higher than PGSQL, right? But if we can replace part of the MongoDB and S3, and we can simplify the process so we can save the additional cost of other components. If we put this red box together, we're actually saving money. And also, the performance is higher, the extensibility is also higher. So right now, we only have 2 engineers understand how to use TiDB or HTAP schema. We are working it fine, and it's helping us confidently building other features on top of that. All right, so I just give some summary for those entrepreneurs to consider about it. So yeah, TiDB or HTAP is easy to use, which is a cloud-native design, make the integration simple, and seamless to scale. This is probably something you also need to consider, because in future, you don't want in every stage, you need to redesign your architecture. And also multi-purpose flexibility. You want to taking care of those transactional issue and also the analytical issue one together. Even though in the HTAP backend, they still have the separate process to deal with it, but I don't really want to hack on that. So multi-purpose flexibility. All right, so, and today I also want to show, so since we're talking about Web3, right? So you might ask, okay, those are the issues you guys are already dealing years ago, right? So what's the difference? How do we empower Web3? If you really think of what Web3 application changing us today is by using the smart contract, many important business logic implemented on smart contract can be verifiably trusted. This is very important intrinsic value of application. But today, smart contract is too stupid because Polygon's smart contract cannot access to Ethereum's smart contract. Not even to mention smart contract can doing the page ranking or doing the SQL query. So this could be a very big challenge for the future Web3 application on the data level. So we're raising some question. Can we allow it to access all the chain's data? Probably, with some proxy, but trustworthy proxy. And secondly, can we increase the smart contract's data processing capability, like allowing the SQL query? All right. So in the last month, we built a demo cooperated with HTAP, TiDB HTAP, and Chainlink Oracle, and the KNN3 data aggregator. We built an application demo, which allows a smart contract to access user profile data from Ethereum, BNB chain, and Polygon, and combine them together and convert into, collect those data into the threshold or the tagging, and intake them into a user profile data vault. And our target is to send those data real-timely into the smart contract so that other Polygon smart contract can access to it. Right. So this is how actually I just said earlier. So we want to collect those data and aggregating and sending to the smart contract. All right. So why it's useful, right? So first of all, why even matter to build this? Right, so if you see those basic profiles, it contains like users' ENS, NFT assets, or those basic information like your name on the RSS3 or something like that. And also we have the assets and define. This has been used by other on-chain on-chain reputation tools to judge whether you have the certain credits. So right now, another application backed by ZK is using our user profile data to build their threshold for their on-chain reputation program. So I just skipped the demo link here. Yeah, those are just some Oracle details, like how we allow the external adapters to access to HTAP database. And then those are the job panels that we are using Chainlink operators to upload the queried data after decoding and fetching and parsing and encode data and upload to the blockchain. So if you go to how do you prove your data is actually on blockchain, right? So the easy way is you go to the Polygon scan and open your smart contract. And we store those data in the event log. So that means other smart contract can access to those event log on Polygon directly and facilitate their own applications by those data. So just try one. And by the way, the performance is actually pretty good, right? So I just query and the responses come here. Blockchain is very, very good at handle those, fixed data. But if you want to track the historical data, it's very painful, right? So the best way is you use the AP job to process those data and convert into the, the fixed data and store it in the smart contract. So people don't think anymore. They just want to fail. They just want to use by the convenience, right? Zoom in, like this. Okay. And also, we also cooperated with another developer tools called Dev3. So we want to additionally, so this is also shared the spirit of KNN3. So we don't want you to spend too much time hacking on data. We don't even want you to spend too much time on hacking your code. So how do we additionally do that? So we partnered with Dev3. So if you want to incorporate with KNN3's data in your smart contract, you can simply go to the Dev3 and find the template of KNN3 smart contract client. And one click, you can deploy your own smart contract with your own data vault without any code. But you have to spend some metrics, right? You spend some gas fee, and your own vault is independently running on the blockchain. So your smart contract can access to it. So even simpler. And this shared the spirit that in future, we want to make it more easy to configure, more easy to deploy, and more easy to integrate, so that developers can use it like a Google App Engine or Firebase. All right. So I just mentioned we aggregated data from the multi-chains and convert them into the, or transfer them stored into the HTAP, and you can use the SQL query to query from the smart on-chain to off-chain and back to on-chain. And what we can use in the future use case, one of the directions one of our customers came out is, hey, look, now I can do the SQL query. But again, I can do the SQL query, but that's in the public view, right? So what if I want to query something more sensitive, right? So like private data. Can I just keep the privacy, but also enable the data availability? So they came up with the SQL query plus zero knowledge proof. So we only upload the threshold or the output of those data SQL query, but not the raw data itself. It also helps, compress the data, so you don't have to waste the storage on blockchain. It's costly, by the way. So privacy and save the storage. And another part is we are going to build an off-chain job management to help the data serving and the computation job marketplace. Well, marketplace means at least you can make it as a product. So you don't have to hard code your job or query on the smart contract. You can go to the job management panel and build your job, and you can call from the smart contract, and you can use the whitelist to control the accessibility so that you can build your own job. And eventually, we're gonna redefine the data economy with backing of Web3 nature. So that means Web3 data, but using with the capability of Web2. All right, so this is the whole landscape I just put together because I just talked too much. So I just try to put them together. As you can see, so KNN3 as a kernel, we not only collect the data in the platform level, but also we convert those data into more usable way, like graph-based or tagging-based or more consolidated way, so that the application, the algorithm for recommendation, social discovery can running their or building their application on top of that. And more important, we want to be, this is the next stage. So more important, we want to not only for our user, we want to bring the Google Cloud style that developer experience to them, and to helping them handle data processing and algorithm building experience. But also, we want to be a proxy between Web2 enterprise solution and Web3 data, because this is very important not only for Web2 companies to finding new opportunities in Web3, but also it's very important to help Web3 data or Web3 application become smarter. Come on, you don't want to use some like 2 buttons and you click and you see something. That's too simple, right? This is not going to be the future of Web3. It's going to be a very robust algorithm. It's going to be very intelligent interaction layers, but without the middle layer, a very strong middle layer, we cannot fulfill that. So KNN3 as a proxy of bridging Web2 enterprise solution and Web3. This is our existence. All right, so last but not least, if you guys have time, you guys can go to the moshmesh.knn3.xyz. If you have ENS or Ethereum address, you just put it into it and see what you have done on this blockchain. All right, thanks very much. And last but not least, we prepared a PingCAP. So if you have an Ethereum account, you can just use your camera, scan it, and put into your Ethereum address or ENS, then you will get a PingCAP. We particularly designed for this summit. So if you got the PingCAP, in future, we're gonna reward those conference attenders. So you will get some surprise, I think. Also, I'm happy to take some questions.
Thank you for sharing such an extraordinary business. So I have a few questions regarding to the usage of the patents and the new restrictions. Could you please go back to the architect part, please? So that I can.
Have you guys done the scanning?
Yes.
Okay. Just back to architecture. This one, right?
Oh, yes. Okay. So my question is, the first question is, what does prevent you using the TiDB at the first layer or first tab? Because we can say still you are still using the ClickHouse as your primary database, right?
Right. That's a good question. Well, actually, I just discussed it with Huang earlier. So there are 2 major reasons. First reason is the data we have been collected from the different blockchain is huge. So it takes time to migrate. And when we upgrade this to the TiDB, so we have to think about that. So that means our whole stream data streaming process jobs has to upgrade. So that's a very tedious work. And another major reason is cost. So right now, I have to be very honest. So without our scale, so if we have a larger scale, the TiDB will be very efficient. But now, since we are still small, the TiDB, at least you got the cluster, right? You got has the, the name. What is the name called? Yeah, you got to have the whole set, even though the data is still small. So it's not economically affordable. So yeah, so when we're growing, but this is our direction. When we grow, so we like HTAP a lot. So when we grow, and we will gradually replacing the parts. And also today I learned a lot from the last presentation. So probably we're considering if we can building something on top of the HTAP by our own or using the industrial capability. Yeah.
The second question is, can I understand the way you are using DB, I mean, not only limited to the TiDB, but also Clubhouse, the MongoDB. We are using a function that basically relying on the stream business. So basically, we want to know in real time, we want to know like how this social distance between me and Index or another Index, or we discover the value of the data on the Web3, right? So can I understand that this is basically we are focusing on streaming pattern?
That's right. So we have the demand on both. First is like a real-time transactional feeding, because that's very important. So let's say if someone follow you on the lens protocol, right? You probably want that following response the circle fast. If that longer than 10 seconds, the people will feel, okay, I clicked twice, 3 times, but this response is not actually running. So that makes the application not very interactive. So we need that real time. But also we need some, so let's say running GN or training a model. Those are merely impossible, even though you're putting more money and put more capacity, still taking time. So you don't want to make that lag as an interaction cycle lag. So that's why we also need a very huge part capability for the AP, analytic purpose or settlement purpose. So that's why we need the 2 parts. That's why we used to have the 2 parts. But now, since in the HTAP, we just put 2 type of data in one place. But still, the process is still existing. So both of them were still in that. Yeah.
And that's good. Third question on the last one is really related to the HTAP, which is basically your opinion about the data availability on Web3 things. So have you ever considered the new Web3 storage method like Aave or IPFS or something like that? What's your opinion on this?
Yeah. So we also use the Aave and IPFS here.
Okay.
Since it's not their conference, so I didn't mention that. But we use Aave with IPFS. But again, so let's take an example of IPFS. So it's very hard normally we use the IPFS to store those metadata. Yeah. That means they are like file-based. File-based. So when you have the index, you can easily access those media, so pictures and those stuff. But if you want to, search it fast, you need to have another layer of the indexation, right? So we are waiting since we cannot do everything in the Web3. So we're waiting for those indexation solution come out, and when that is ready to use, and we were not replacing our current storage component, but for the delivery part, for the data delivery, we're probably using that indexed IPFS solution for our external user. Let's see, it's an open protocol, so you don't need to you don't need to do the access control. So that means a large traffic came in. You don't need to handle it. Why? Because we put it in IPFS. As long as IPFS is running, you can access to it. And actually, I can show you this case. In a Quest 3, all those data are put into IPFS right now. So even though their user increased from 100 to 10,000, we don't have to worry too much about the traffic, because all those traffic go to the IPFS. Yeah.
All right. Thank you. Thank you for your insight.
Yeah. Thank you. Yeah. Is there any other question? All right. I think that's for today. Thank you, guys.
Thank you.